Okay, for people joining our live stream, we are talking about machine learning functionality for the upcoming version of Wolfram Language, and we are, I hope, in the late stages of dealing with a bunch of unsupervised machine learning functions.
Yes.
Okay, missing imputation, the names for missing imputation. Yeah, I mean, I do not like the name imputation. I think it sounds accusatory. And the default thing that how are we defaultly specifying the data which is considered to be missing?
With a missing symbol.
With the actual symbol missing?
Yes.
Okay, with some possibility, presumably, in the function to say, this is what I want you to consider to be missing, like green screen type stuff.
Well, this we didn't completely decide, but yeah, that could be one way of specifying missing. Actually, at one is a meeting, we kind of agreed to use, what was it, Amir? Missing data token?
Token, yes, missing data.
So to be an option, missing data token, or was it with a rule after the data?
Yes, it was just missing data token.
Say it again, missing data token? Okay.
Yes.
By the way, somebody on our live stream is saying they're hoping this is about the next iteration of the neural net framework. Unfortunately, this is not. This is about uses of it. Maybe we'll live stream the discussions about what's going on with the neural net framework. It's quite interesting. Actually, there's on Friday, I'm seeing on my calendar at 3:30 Eastern is supposed to be something about that, and maybe we'll have a chance to live stream that. Oh boy, we've got a lot of these meetings coming up. Whoever thinks that people are on here looking at the calendar, whoever thinks that the text cases meeting is going to happen at 11 a.m. Eastern on Friday is wrong. It's got to be an hour or two after that. Anyway.
All right, so should we set in stone the missing data token then? Option? I mean, that's what.
No, because we've got to have a name for the actual function. Okay.
This is a thing. Okay, it's another thing, but.
Right.
No, so, an option to specify the missing value.
We're agreeing that there's an option. What the name of the option is, we're not sure
yet.
Yeah. And Shadi, is Shadi on the call?
Yes.
Okay. So do you need, I mean, for image processing and so on, and for audio and such like, you also need to have some kind of missing. Do you need the notion of a missing data token that could be, for example, some shade of cyan for a green screen or something? Did that make any sense? For example, for in-paint, how are you specifying? So for in-paint, you're giving a mask that says where the data should be considered to be missing, correct?
Correct. It has always been a separate image.
Okay, but so you could imagine a version of in-paint where you say, whenever the thing is this color, in-paint there, correct?
I think it's a different way of specifying a mask. So we have that now with colors near and so on.
So wait a minute, remind me how that works for the case of, so you're saying, okay, so.
You're unlikely to have a very crisp color, you know.
Yeah, I know. What is the name for the colors near? What is that? What is that called?
Color detect.
No, I mean, what are you saying? No,
What are you after?
What I'm after is, how do you turn everything that's near blue into something else?
Color detect. That's a new in 12.
What is it called?
Surprised. Color detect. I'm surprised you don't have it.
Well, this is the head branch build.
Right, it's in prototype.
Okay, I can start that just for a second. But so then how does that work?
There is a ref page for that as well, but you would say color detect image, cyan. And then it will give you a mask, could be a binary or grayscale mask with all the pixels near cyan.
But didn't we have a function? Didn't we define a notion of, we talked about functions, colors within a certain distance of such and such a color.
Okay, so colors near.
Okay, so we have colors.
It was called color neighborhood, but you came up with this other name.
Okay, so colors near red. So we can say something like image replace. So let's imagine that we have
Recolor image.
Image of US flag, for example.
Mm-hmm.
Oh, come on, what's this doing? Yeah, there we go. Okay. Okay, so then what we say here, if we want to replace the red there, so what would we say?
Image recolor.
Image recolor, okay.
That's another new function coming.
Okay.
Of that image.
Okay, so colors near red goes to green, for example.
Correct. And that red is probably too far from the red.
So let's say I say 0.2 or something. What does that mean? I mean, that should be, that number should be, oh, wow. Okay, so that 0.2 I would imagine to be distance across color space.
Correct.
And how can it need 0.5 for that?
Red, the RGB 100 is fairly far from that red. We have also added fine matching color, another function that you can give it the image and say red. It will give you the shade of the red.
All right, okay, but so for in paint, for example,
but I don't want to detract, but I just wanted to do one comment on this. Maybe we would want to do a bit of clustering. Maybe sometimes you want to, like I can see that the flag, you still have some lines of red that are probably a bit darker below. And I don't know, the intuition would be, here is an image, I want things that are close to red. Maybe we can actually use this image to figure out what is close to red rather than having a hard limit.
I don't disagree with that idea.
Right, we don't have a hard limit too. We have some smoothing going on, but probably that's still too far.
Okay.
Okay, fine. Okay, so the point I was going to make about in paint is right now, if I said in paint this flag, right, with the only way I would do that, I could imagine saying in paint that flag for every colors for all the colors near red. See what I'm saying?
Right.
Which won't work right now. But that would be treating like missing data anything near red effectively.
Right.
Okay.
In 12, if you do color detect, if you add a color detect around that color near, well, you would need the image again as well.
Yeah, okay. So color detect. Did we agree on that name? Yes, it's like edge detect. Right. Okay, so now I do that and it'll be a very exciting flag.
I don't know why it inpainted everything. Maybe color detect is using a different distance function in colors near. I'll look into that. But practically, this should give you the same mask.
Just run color detect and see what mask comes out.
Yep.
Well, that's an everything mask. Who knows? That's really weird. That doesn't make sense. Image recolor didn't recolor the things. Oh, I see. Those are stripes. Image recolor didn't recolor at 0.2.
They're using two different distance functions. No, they're just using two different distance functions. We have to make those consistent.
Okay, all right, okay, fine. So this will now in paint. Yeah, okay, fine. A little weird, but okay, fair enough. Okay, so back to the missing imputation stuff. Okay. Okay, so the idea is we're filling in data that is considered missing. Now, notice that in paint, what is the second argument for any of these missing imputation functions if it isn't?
So you can see above. So missing imputation, second argument can only be a property. You can give new data. It's really about either getting out an imputer function or getting out the imputed data, and you can have both if you want, by putting a list of property as second argument. The imputer function, you just use it, right, on your data. And the missing impute, that's the one that you can either just give data to be missing, or you can give, let's say, a learn distribution as the first argument, and then the data to be missing, or built-in learn distribution as the first argument that we won't have.
Why do we even need that first argument? I mean, if the data is an image, then this is what you want to assume, right?
Okay, yes, that's... okay,
as opposed to self-learning, right?
Yes,
it's going to be much better to transfer learn from a big data.
Of course. So that's, okay, that's a very interesting conversation. Right now, the way it is set up, it's a purely self-learned function. When we'll have built-in feature extractor, which are complex because they have to be reversible, actually. Yeah, actually, it will be a bit complex because we cannot just, anyway, transform the missing and impute in some feature space and then go back. We have to do some more complex, so it might be slow. It might be slow stuff, but nevertheless, when we have these things, then we can have a mix of a lot of prior knowledge, so to speak, about image and whatever, and things that we learn. It's still a bit a hybrid. I don't know if we have the same in feature extraction that has some feature extractor, but also learns from the data. So I don't know if we want to continue in this direction.
What is feature extraction? I mean, feature extractor, you just give it the data, or you give it a prior set of things and the data, right? Like this.
Yes, you can get a feature extraction method. Yeah, sort of. You can do face features, image features, so you can specify this. But even if you don't,
where do you put that in the argument structure?
It's second argument. Let's see. I mean, okay, let's look at documentation.
I know the documentation is broken for this. Okay, so you're saying feature extraction.
It is, yeah, it's a second argument. Second argument, you can put a named extractor or extraction method, which...
Okay.
And which you can see the list if you open the details and option. But even in automatic mode, where you just put example, what they will do is use some built-in, but then learn on top of that as well. Which might be confusing for the user, because let's say you put the same image 100 times. It's not the same as if you put just one image. And actually, if you put the same image 100 times, it will reduce the dimension to just one number, because it will say, well, there's no signal in this data. It's all the same stuff. And that, I think, can be confusing for some user. If you have repeated data, suddenly, it's quite of a different behavior. So I can imagine a user that doesn't just want to fill in missing data, but that doesn't know about machine learning, doesn't want to know what machine learning is even, just want the thing to work. Let's say the repeated data.
This is a can of worms. I mean, this is basically saying, realistically, how useful is the self-learning stuff? Is it useful, or is it kind of cruddy?
Very useful, very useful. So all data sets are different, basically. I mean, unless...
Yeah, okay, I understand. So like anomaly detection, clearly self-learning is useful for anomaly detection.
Yes, it's like your data, let's find anomalies, or your data, let's impute missing values. Now, for the case, I mean, it's really concerned the case of images, text, and sound, right? Which is kind of this universal data set. You might expect people to impute the image or the sound or the text, and without learning anything. And I can see some misunderstanding.
Well, that's essentially what InPaint is. I mean, InPaint,
yes, exactly,
is basically the analog of missing impute for images. So let's talk about that for a second, okay? What is the analog of that for audio? Maybe it's its own function. Shadi, Roger, do you have an analog of that? I mean, in other words,
No.
if there's audio, I mean, but clearly we could have.
But there are in sort of signal processing, when you think of more smooth signals, yes, they you know, a typical scheme used is that you have a model for the signal, right? And then you, which is what's used for this. It's basically what's going on in this missing imputation here too, but they're just simpler. You know, you have, you know, kind of like
LP, linear predictive coding and stuff like that.
Stuff like that. Yes, exactly.
Right.
But you know, but smoothing is when you use the signal on both sides. Let's say you have a gap in the signal, then you got to use the smoother. You have to predict from both ends, so to speak. You have to use the information on both sides.
Right, but in the case of audio, it's like scratch removal, same as with images in some sense. Well, scratch.
Yeah, and it's still called in painting. Or at least people refer to that as in painting as well. I don't know what other terms has been used.
I see. So how does, I'm sorry, does in paint have a default second argument?
No.
Okay. So in principle, in paint could have a default second argument, right?
Sure.
In principle, in paint could do anomaly detection to find out what things seemed like they were anomalies in the picture.
I mean, this would be more denoising or error correction. This would be another function, I think.
As opposed to missing imputation?
Yes.
So are you saying that missing imputation, well, okay, fine. But isn't that what we want to do? I mean, the audio case where you fill in the missing, what was it? You know, and the Watergate tapes or something, I forget what that was. You fill in the missing whatever using missing imputation. That's pretty silly. I mean, I don't see it being used for audio. Do you?
Yeah, not so much.
Image
would be the main, and I don't know if text.
Text, can it be used with text? You wrote something that's obviously a missing word, and we impute it.
Right. That's a different and exotic piece of functionality.
That sounds very.
Yeah. Error correction is more the type, or denoising of text, so in a way, is more the useful function. So it's true that it's
I'm sorry, what is denoising of text? What are you talking about?
Error correction.
You mean spell correction, for example?
Yeah, I mean, spell or grammar or, you know, I mean.
Yeah, but those are different and very exotic functions that really, that are built from the corpus of, spelling as a societal construct, so to speak, built from the corpus of all word spelling, not built from your individual corpus, probably. I mean, in other words, from your individual corpus, you might have misspelt the word commitment or something, all through your documents. You don't really want it to self-learn from that document and decide that's a new word.
Yeah, I mean, you can do that for a new language, or but it's true that these functions are more useful in more classic data.
Yes.
Because
for right. So what we're concluding more or less is if you want in painting, use in paint, and so that this function here is mostly filling in missing data. That
something else indicates that it's missing. You've tried tokens and other ways to point out what characterizes missing.
Right. Well, the concept here is that there's a missing data token where the default is basically, underscore missing, correct? That's your concept here, right?
Yeah. Yes, that is correct. The default is just missing.
Right. So, which kind of elevates missing, which we want to do anyway. Unfortunately, we're going to end up with a calculus of missing data, as we perfectly well know. Like, our three missings. If you take the mean of some data and it's got missings in it, how do you handle the missings and so on?
And Determinate does that well. Actually, internally in the machine learning code, we use Determinate extensively instead of missing because it has these properties.
Does indeterminate work with mean correctly?
I think so.
I think that should come out as indeterminate. I think it poisons computation.
Yeah.
I mean, you could remove the indeterminate in that case also, but
no, but that's the point. It's not doing that. I mean, what we need is a calculus of missings where, I mean, what do we think that should come out as? 1, 2, 3, mean of 1, 2, 3, missing. I think it should come out as the mean of 1, 2, 3.
Yeah, you're right. It's a little bit different. I mean, in many cases it will be the same as indeterminate. In some cases not. So in that case not.
Right. In this case, it's really.
What is nothing?
You know what nothing is. Nothing is nothing.
Oh yeah. Right.
Okay. It's a very useful thing.
Yes.
It is actually.
Which is okay. All right, so let's come back here to the name of this. So let's explain what it is that it does again. So it fills in missing data, right?
For the verb version. Missing impute, missing fill missing, data impute, whatever you want to call it. This
the word impute is just not a winner in my book. Who was not as a native English speaker, I know what that word means, but it has a sense of accusation. For the non-native English speakers, did you even know what the word meant?
Yeah, actually, yeah. I don't know why.
You're well educated.
I think we have that similar in French. I think that's why.
Okay.
I'm getting confused, but
well, maybe it means something different in French. Who knows? Okay. So I just don't think it's a winner of a word.
All right. Well, here is one vote. I looked it up first time I saw it.
Okay. Fair enough.
I didn't know either.
Okay. This is bad.
I mean, I knew the accusation version, not the imputing missing data. This I didn't know as well. Before.
Okay, fine. So this word is a loser.
It's a loser, but on the other hand, it keeps it into the realm of machine learning. I'm just scared of the misuse. In the same way we had for feature extract. How many times you sent an email about why doesn't feature extract work for one image? Or things like that. And because it the name gives the wrong expression that it's not a learning function. Well, actually it is a learning function. So maybe calling a name a little bit more obscure will keep it in the realm of statistics and machine learning, and people will understand. Well, okay, learn the data, and it's a do-it-yourself thing. It's not a,
Well, it isn't a do-it-yourself thing. It's a very nice, package thing. I mean, if your argument is let's give it an obscure name so nobody knows to use it,
not that.
That's a bit self-defeating.
I agree. It's not plug and play. It's plug and play in a way, but it's still do it yourself. You have to give your data. It's bring your own data type function.
Right. Okay, and you're right that it shouldn't give a sense in which, it is a statistical, what does it really mean? It is kind of a statistical, filling in of missing data.
Yes. For example, let's see what kind of example, like you cannot, solve this sort of logic puzzle where you have 2, 4, 8, 16, and
right. Right. The word inferred might be, because that's what's happening. It's inferring from the data that you have.
Infer missing value. Infer missing.
Mm-hmm.
Well, but it's filling in the missings. So that's what we want to do. It's replacing missing. It's replacing missing values with inferred values, with statistically inferred values. Well, with machine learning inferred values.
Yeah, I should give a. I don't know if we ever gave a short demonstration.
Sure, give us a short demonstration.
Let me prepare it for 30 seconds.
Okay.
So I can find a nice data set to.
All right, but let's I mean, infer missing values, I believe that people would understand what that means.
Infer, yeah.
Okay, what would if we use that form, what would these different functions be called? So one would be called missing value inference function.
Whoa, that's yeah.
It's long, I guess but so what?
Yeah,
it's okay. You're never gonna type it.
Yeah.
And then what would some of these others be called?
So
maybe you don't even need value for the inference function.
So there would be the missing inference. Missing inference would be the one that returns the missing inference function, or missing inferer function if we want to be it's weird, but if we want to be consistent with the other unsupervised learning functions.
I see. That one would be missing value inferer.
Or as Roger said, maybe without the value, I don't know. Like missing, yeah.
Or missing inferer.
A function. We still put function, but yeah.
Okay.
Missing infer function, missing inference, infer missing.
Wait a minute. Missing inference is which one? And then
this is the one that returns the missing inferer function. And infer missing is the one that acts on the data.
Have we ever had to do that in other cases where we flip around the words?
No, we didn't. So it will be missing infer. If we want to be consistent, it will be missing infer. Like, like dimension reduce or feature extract.
It's better than impute. It's a lot better than impute, in my opinion. So missing infer in this case would take the data and it would try to remove missings by inferring, attempts to infer from the data how to fill in missing values. Is that correct?
Yes. And
actually, more accurately, fills in missing values by inferring them from the data, by inferring them from the structure of the data.
Yes. And in practice, it models the data with distribution and use that to sample. Actually, I think I'm ready if you want to.
Okay, but hold on. Fills in, I'm just trying to get what we would call this. Missing infer. I don't really like this. Missing infer, and that sentence is just, missing infer is just totally weird because it doesn't say what it does. I mean, the fact is, infer missing values says what it does.
Well, what's wrong with that name then?
Well, then what do we call missing inference?
Which is producing a function out.
Yes. So let's imagine that this one was called missing value inference function.
But that's the only thing. That missing inference, it builds the distribution, right, and creates the function that can then simulate and infer.
Yeah.
Yes.
And why do we have to have separate functions even?
So
couldn't there be a second argument that says, what the hell it does?
Well, the problem with that is that what's happened here, and we could get around that in this case, because we don't actually believe the prior distribution is all that interesting here. We believe most of the time you're going to be self-learning.
Yes, but this is one way to use distribution you already learn for other reasons, for example.
Well, okay, but so here's a possibility. So let's say we said infer missing values, and what you've got is pure data. So we could have, prior distribution, arrow, and then your data if you wanted that case. Or you could say infer missing values of just data like that. And these would return, okay, so this would return the data. How common is it going to be to want to generate
a missing imputer?
Yeah, and why is it different? Why is a missing imputer different from a learned distribution?
Potentially, we could use non-distribution that can know how to impute as well. But it's true that we will, at least for 12, it will be only learned distribution. We manage all non-learned distribution, we manage to make them fit into distribution type things for now.
So wait a minute. So then what difference is there between simply saying learned distribution of the data, of some prior data, and then feeding that in as the prior for infer missing values? And why do we ever need a missing imputer function?
So, okay, for two reasons we might need it. So it's true at the moment there's not much difference. But the first reason is what I said just before. We could have other methods that do not learn the distribution. Why not? Something that is faster, and I don't know. The second reason is that you're declaring your intention of inferring missing values when learning the distribution, and we can use that. There's some methods that are very good at let's say, generating new data, synthesizing data, but not good at inferring missing values. So at the moment, all our methods are quite generic, but as soon as we start adding more powerful methods, they will become specialized. This one is good at imputing, this one is good at generating, this one is good at querying the PDF. So for anomaly detection.
Okay, but so what we need is you'll want somehow, instead of that prior being a learned distribution, you want that prior to be something that is more specific to this. And in fact, your missing imputer function would have to be given a whole new data set. I mean, unlike classifier function, which is given a single element and is told to classify it, this is basically a big data set to data set transformer.
It can be a single element as well. No, this one, I mean, yeah, it can be either one example or many examples, and it just used the distribution learned before to impute.
Okay. So the issue is, okay, so you know what? My claim is going to be that this should be part of learned distribution. That is, that learned distribution should have some advisory options that say, this is going to be used for missing imputation.
That could be one thing. Still, let's imagine you have your data set. I mean, we need at least, okay, maybe we don't need all this function. Okay, it's just about missing input, about the inference one that you don't want.
Yeah, I'm trying to see whether we can just get away with one function here, infer missing values, whose name I like a lot.
Actually, that could be right. That could be right. Let's see. I mean, as long as we don't have other methods, that don't use learn distribution.
Right, but I'm even saying if you
and then here we need this option, so it's kind of a goal to learn distribution task goal. Or I don't know.
Exactly. Yeah, right, exactly. Optimize it for this.
That could be. By the way, do you want that I do the demonstration? So it might.
Yes, although I think I'm pretty happy with this actually. I think this is good.
Mine.
I think infer missing values is a function people will actually use, as opposed to imputation, where they'll just feel that somebody's being accused of something. All right, let's see the quick demo. We're a little bit running out of time, but let's see the quick demo.
It's going to be very fast.
Go for it.
So, actually, let's not spoil anything. Up. So it's just using learn distribution, actually. So here I have some data, okay, just bidimensional data, so we can see what's going on. It's learning the distribution. And you can, by the way, see some information about the distribution if you want. Let's see, I don't know, the algorithm that have been tested and so on. Sure. And this is a contour plot that will show the PDF of these things along with the data. So just to get an idea. And actually, this is an internal function we use right now, something like impute, first argument is distribution. Then you put the data with some missing. So here, the X is 7 and the Y is missing. So it should be something in this area, right? And it's missing by sampling. And
I'm sorry. When you ran that a second time, let's impute. What on earth is going on?
Okay, so it's conditioning the distribution on the fact that X equals 7. Right? So
I understand, but then it's a random variate?
Oh, yeah.
Definitely.
That's how it all works.
Definitely. That's very important. And that's actually the next item on the agenda.
Is the random seeding function.
No, not that. That I'm not worried. It's how do we specify, because there's two ways. You can either sample or you can maximize the PDF. Get the mode or the commonest in a way.
Yes.
So how do we specify that? So it could be with a third argument by saying sample. Actually, it simplifies things a lot if we just use one function. Because when it was learning the missing imputer, we had kind of two methods that were conflicting. There was a method about the distribution and the method about do you sample or do you find the mode? And they were kind of conflicting. So in terms of design, it was a bit hard. If we learn the distribution separately, then we can just use the method option. I don't know.
Well, okay, let's come to that in a second. That's a really scary thing that I had not internalized, okay?
You're scared of random.
I'm scared of random things because our users hate them. I mean, then we get tech support questions. Why did I get a different answer?
Yeah.
Why did I get a different answer from this friend of mine? And people have a theory that, it's like the conflict between randomness and science in the world, so to speak. People will develop a theory. Oh, I got a different answer because it's using because my computer has a different revision number or something.
Yeah, I think it's relic of the fact that our CPUs are deterministic. When our CPU will be probabilistic, we'll be much more happy with this.
Yeah. Okay. And then we can.
But but it's important to kind of see the. Oh, and it's also important when you have two modes. So, for example, if I do in 5.5 here.
That's an interesting theory of the end of certainty in the world. Sorry, I'm just using on that question.
So here you see 1.5. So here is in the 4 region, but it might jump, I guess, in the 1.5 region if we wait. Actually, let's do this with.
So why can't you generate from one of these functions a conditional distribution here?
I think we should at some point, and that should be. It's kind of included in the. I mean, it's allowed by the current. I mean, it's not forbidden by the current design. So you'll be able to take the learn distribution. So it will be post 12, and do something like.
Well, this is effectively a conditioning of the distribution on
exactly. So it might be something like 5.5. I don't know. This would be a bad way of doing it.
And no, I don't. But I don't think you should use missing to do it. I think it's a question of. I mean, it's a different case. It's a different case. Gosh, what are you doing here? What it really is, okay, is it something like 5.5 comma x? Yeah, what it really is a scoped construct.
Yeah.
Right. So here's what I think it is. I think it's a here. If you let me well, it will be something like 5.5 comma x.
Sometimes they are named, so it can be something like that.
Okay, fine. But what I'm suggesting is that this is a scoped condition distribution, right? So in other words, you say, yes, condition distribution. It's not learned distribution. It's just condition distribution.
Okay.
Okay, and then I'm saying conditioned of, and then a distribution like that distribution of that thing of that distribution. That distribution, not the condition distribution of let's say open brace 5 comma x. Okay, now the beginning of condition distribution, put list x. Okay, so in other words, what that's doing is it's really what that is actually what you really want to say is conditioned. It's a distribution. It's some kind of distribution function, right? Instead of condition distribution, that really is something more like a distribution function.
I mean, yeah, this one would be distribution function, but we could imagine doing other things afterward on it. So I think it should.
So, by the way, conditioning is a big hole. Most people think that they know conditioning because they know to be able to condition on linear equations or just values, which is particularly simple linear equations. But it needs to do a whole lot more. The range of what you can condition on.
Sorry. So Roger, but do you have a framework for how to represent conditioned things?
We avoided it until we got more experience with it, because the problem is there's a certain kind of thing that people think that they want, but it turns out that it's way more general than that. So basically you can condition on any event. So that means that the things that you see textbook-wise, conditional density and so on, are just conditioned on values. Yeah. So just the case that you saw, okay? But that's not nearly enough what you need. You need to be able to condition on any event. You're on an algebraic surface. You're on a.
Okay, so you already have. I didn't remember that you had this condition thing. I now do remember it. So
right. So probability and expectation take conditioned, okay? And we have internally something that's effectively a condition distribution, but to roll it out, we need there's a.
Okay, but so wait a minute. What's the correspondence between your conditioned thing and what Etienne is trying to do here? Do you understand that correspondence or not?
Yeah, I'm just worried that it gets rolled out here and it's a design that's a dead end.
No. I'm not suggesting we do roll it out here. It's not needed yet by Etienne. I'm just trying to understand.
Oh yeah, we won't have it that in 12 for sure.
Right. I'm just asking the question, Roger, if the thing that Etienne wants to do is it design extensible from conditioned.
Conditioned is made, to be an inline, the condition typesetting construct. Okay,
it's one shot.
Yeah, like that one. So that's usually what's used, a vertical bar. Okay, and we redesign something that's not just a vertical bar because that means so many things.
Actually, it's not that much condition. It's more like this is sampled according to the distribution.
It's not sampled, it's distributed, but what you could do is to use probability or improbability with some condition to find, for example, a CDF for your, learned distribution conditioned on some value. Because you're fixing one component, right? So you can say, y equals 5, and then find the probability that x is less than, something, and that's gonna give you, in effect, conditional CDF of your conditional distribution in that sense.
All right. So listen, I think there's a sub-discussion here about how to do conditioning.
I'm going to give you back the string.
But I'm just saying that everybody thinks they know it, but they really don't. You know, because they have use cases that they're familiar with, and it's important to them. So I'm not just dissing that at all, but they don't know the full scope of it by a long shot.
Okay, Etienne, can I have the screen back?
Yeah, I want to give you. I just want to show you that when you take
it's magnificent.
5.5, then you have two modes. Anyway,
it's magnificent. What do you mean that was two modes? The mode is the mode, isn't it?
No. Yeah. Well, it's not defined when there are multiple modes, right? What the hell is it?
Okay, so what you're telling me here, okay, so
two local modes. Yeah, so we need to find a way to specify, do I want, the most likely value or sample, which when we have one function.
We have a similar thing with sequence predict, don't we? We had which was pretty horrifying.
Active classification. Active classification, it's the number 3, where you have an association. But if we have only one function, then that kind of changes the deal because learn distribution will be trained separately. So now we are free to do whatever we want. Either an argument, that's the proposition number 4. If you scroll down a little bit. Either an option, method option, or option with another name, like we can do whatever we want.
Okay, so I would recommend here, so in our infer-missing values, oh boy. I hate generating random stuff without telling people that's what we're doing. I mean, one possibility, which I think you were proposing, is method arrow random.
It will be the default, by the way.
That is so freaking horrifying. Well, so long as if you have random seeding and your random seeding is 1, 2, 3, 4, I'm okay with it.
No. It's not possible.
Why?
Because that would be even worse
than giving commonest. Look, okay,
name a function. You want to be able to sample, otherwise you cannot sample. If it's random, but random seeding 1, 2, 3, 4, how do you have to change, but you have to put method random seeding, and then put what? I don't remember, inherited.
Well, okay, so wait a minute. I think the name infer missing values does not suggest that that it's like a random variate. In fact, none of these names have suggested. In fact, it's the first I've known that this is a random function.
It's actually dangerous. Let's say you have a data set, and you infer by the most likely value.
No, I know that's dangerous.
And then you compute the mean. The mean will be completely biased. Whereas if you sample, the mean will be non-biased. Also, it really shows the user the uncertainty we have on this imputation.
Well, then I would suggest, I mean, after all this work on the name, at least we managed to get from the name, we managed to get down to one function. Let's consider names for that function that are things like sample, that involve things like,
no.
I mean, is there a possible way to get
sample missing value?
Resample missing values? Yeah. I mean, you get what I'm saying. Go ahead.
I mean, this resampling kind of collides in my mind with what we have as a time series resample when we actually deterministically resample the signal.
Right.
So then it's deterministic. How.
You're right. This is a lose. Yes, we can't use the word resample.
If we make it an argument, maybe a bit more stronger than an option. If I use a sample mode, I mean, maybe other names, but like it's not hidden. It's not like, I don't know. Yeah, I agree it's not in the name of the function.
Yeah.
It's even clearer.
Well, I mean, but the way you would expect to use it, is it the case that, see, random variate, it's very clear what you're getting.
Yeah.
But and the different name for random variate is sampling.
No, I know.
Or simulate is another name for it. Just
actually, yeah, some people use simulate, yeah. For
simulate missing values that would tell you that it's simulating, right?
Yeah. But simulate doesn't simulate. That's sort of interesting. I agree that simulate missing values, I would expect that to produce something. It could perfectly well produce something random.
And so would sample missing values.
I don't know what that means, because sample means, to me, means pick them out.
Okay. The other meaning of sample is just like generating.
I know. Generate.
Distribution, yeah.
But then it's, I think, to you'll avoid the confusion, you just use random sample. Then you know that your creation is random.
Yeah. For many people, simulation means deterministic too. Like
I know that. That's the problem that I'm having as well.
That's a very long name now.
Yeah, it's horrible.
But we need to be, I don't know.
Okay, let me give you a less good sounding name. Randomized missing values. I mean, then it will be very clear.
It's very clear. I feel people will think it does nothing.
Yes, but that's okay. I mean, the fact that it doesn't do nothing. But I agree. Okay, so a suggestion from our live stream is synthesize missing values.
Actually, we thought of a function that would just do sampling, from data, learn a distribution, and then just do
sampling. We want to call that synthesize, right?
Yeah. Which there's also actually now that we go into the task goal route, maybe this could also be part of learn distribution, and it would be like a sort of task goal synthesize, or I don't know.
Yeah, right. Well, you just say random variate of,
and then you do random variate, exactly. So it's really the two choices: having more functions or this task goal thing.
Well, I think that some functions. Look, actually, I think synthesize missing values. Thank you to Carl Lang for that suggestion. That to me is the most promising of the ones we've seen here. It suggests that it is randomized in some way. It seems plausible that will be randomized. It suggests that it's using something from the information that's already there. I like it. What do other people think?
I like it too.
Yeah, I think it's good.
Wonderful. I can't even, oh yeah. There we go.
And we make it work with the learn distribution. So, okay, if there's only data, it will learn from the data. And if there's a learn distribution and data, it will use a learn distribution. And that's it. Oh, and the sample mode thing.
Yeah, right. So then the method will be the default method then.
Oh, we still have the problem. Sorry, I forgot. We are not only learning the distribution separately, right? Because if you just put the data, it will learn from it. So we need to both specify the method of learn distribution, and if it's a sample imputation or mode imputation.
Okay, all right. Oh yes, sorry. On our live stream, Bry C was actually the person who suggested this. I can't read. Thank you. Okay, so wait a minute. So you're saying that there are two methods here.
Yeah. For example, you could have method multinormal. Let's say this would be the one of the simple methods for learning and distribution. And you might only want to say do a sampling or do a sort of optimization to find the mode. I'm not so fan of the association. It's a bit
it's a mess.
Clunky. So the two things that I like the most is either having method for multinormal and so on, and then evaluation method, which would be an option we use in other places as well, because it's quite classic in machine learning where you need to specify the method on how to train and the method on how to evaluate. We can actually.
The word evaluation method sounds awfully general for a lot of other things.
Yeah, true. But maybe it can be used in many other things. I don't know.
Where else would you use evaluation method and things you know?
So active classify definitely would replace this association in two things.
Wait a minute, which association?
So go down, here you go. In the form method association can have element evaluation. Actually, it's called evaluation strategy, classification method. So classification method would just be.
So by the way, I mean, clearly for synthesize missing values, the method specification could perfectly well work the exact same way as it does for active classification.
Yes.
Where it could say evaluation strategy, which is a good name, I think. Look, I think this is what we should do. I think if it turns out people are resetting this all the time, great, we can have a more serious option. But otherwise, evaluation strategy, let's say random sampling, or what do we call it? Mode.
Mode finding. Mode finding.
Mode identification sounds more fancy, but okay, and this would be learning method, right?
Learning method, yeah. Yeah, or model method, or I don't know, modeling method, distribution method. I guess we have classification method, so it should be distribution method.
Why?
I don't, because it's.
But it's not the distribution. It's. I mean, it's really the learning method. It's going to turn into. It's going to be the learn. Look, it's basically distribution learning method, shortened to learning method.
Yeah. And you don't like the arguments?
I don't think we care. If you tell me that it's most sensible to
do random sampling,
that random sampling is by far the most sensible thing to do. Yeah. I kind of agree with you. I think it's just a formula for people to get themselves tangled up by using, it's like I can imagine all sorts of, because I mean, when you say, if you're filling in 25 missing values, you're filling in the mode of that distribution. The mode of the 25-dimensional distribution is a difficult thing. I can't even find it.
Yeah, actually, many times I will resort in sampling many times and taking the most likely of the samples.
Of each sample?
Yeah, I would sample like 100 times and get the one that is,
Okay, fair enough. But that's okay. So.
But you're right that it's easy.
It will bias tons of things.
And to find the mode, it's harder for us, and it will bias. So I'm actually happy with this.
Okay, fine. All right. So.
Oh yeah, this is a big.
Well, look, missing data. We're agreeing. What's happening right now is it's missing data.
Token.
Yeah, it's kind of lame because it's. Why is it missing data pattern? And why isn't it missing data pattern? Like you should be able to give any.
You don't know to have the default underscore missing.
That's correct. But token is not something we use very much. On our live stream, folks had suggested missing handler, a missing substitution system, but that isn't quite right because it's not quite a handler. It is what constitutes as being missing for purposes of let's see, missing. Okay, so what is this doing? This is, I mean, this is a stupid name because it says it's misinterpretable in a million ways. And the problem is missing data token understandable, or is that, parsable? I mean, missing token is kind of absurd because that is like, it's missing. Where is it? Type thing. Actually, given the name of the function, missing value token would be better. Wouldn't it?
Yes.
Okay, missing value. Whoops, I just filled in. Yeah, missing value pattern, but we don't usually use pattern to represent. We just say
missing value indicator, missing value.
Indicator. Right? What's that?
Yeah, something more vague where we can put patterns and other things. Because
what else do we use for things like indicator? Go ahead. What were you going to say?
Because we could also think that I'm not, like these colors near. It's not really a pattern. It's I don't know.
Yes, I understand.
The name financial indicator. There's about 100 of those.
Right. But let's imagine that we wanted missing value. Look, I could imagine this being. Okay, so let's try some things. I mean, okay, so look, let's fill in some things which might be useful here. We might say greater than. I mean, almost this is missing value function. Okay, so one possibility is missing value function. Okay. So another possibility for that would be
90% of the case it would just be a token, right? So
well, yeah, it could be this though. That would be useful.
Mm-hmm.
Now, alternatively, look, I can see missing value indicator very often being, negative values, for example. Your machine is reading, I don't know, pressure of a something or other, and its indication of an error is a negative value.
Yeah. Again, we'd go in discussion about, is it missing value or censored value? In that case, in that very case.
Right, but we're talking about, I mean, this is. Okay, so one possibility is a missing value function, because then we could just say negative, meaning it's, but then we also want. I have to say that I'm thinking missing value pattern is the best one, because, the default is underscore missing, but another possibility for missing value is, 99 might be a missing, or -1 type thing.
Mm.
Now, possibly, if the data is huge, you may want some fancy way to process the pattern values. I like this missing value pattern. Objections from people?
I'm good with that.
Anybody from statistics? want to comment on this? Because we're going to end up wanting to use this in statistics functions at some point. Seems reasonable to me. Let's just talk for a second about import. What does, like, for example, when you import a spreadsheet and there's something that's just missing, what does it return? Does anybody know?
I was looking at it. We have fill rows where we have rows with less elements. And then we have, and that's an option, I think, for CSV and Excel. Then also we have empty field option, a string empty field that says what to put in those empty fields.
I see. Let me just look for one thing. Let me just look at one thing.
So we have something called missing data rules. That is a string. Get documented.
What is that?
I guess maybe missing data rules. That's something of for semantic import. That both specify what is missing and what to replace with.
Oh, so that's the same thing we've been talking about.
I don't know why the example have strings in them.
Well, it's interesting. I mean, that's a closely related thing.
Yeah, there's a bunch of related, I don't know, missing data method, but
what's that?
An option in temporal data and other functions to control how to process missing data. So for example, missing data method, interpolation. So I guess that could be used by the learn distribution. Like could be missing data method, learn distribution when using.
Yes, absolutely. Missing data method goes to learn distribution.
And we could use this option in classify as well. And other functions. I mean, actually all machine learning functions.
That would be nice. Missing behavior. Okay, listen, we need a separate discussion about missing values. I think for these purposes, missing value pattern is okay. But we may want to put that into things like in-paint and so on as well. Any objections here?
Nope. I was also thinking delete missing itself could take whatever option we come up with here.
Yes, that's a good idea. That's an excellent idea. That's a minimal idea and an excellent idea. Yeah, absolutely should. I mean, clearly one could always say delete cases, but this is a convenient kind of
so the one that we have now that fills in missing, this one deletes missing. So they're kind of paired.
It is, yes. Do we need the word values in here?
Probably not.
Makes it a little clearer. I mean, we could get rid of value in both cases. Missing pattern. I hate that. So obscure. You know what? This is nice. This is clear. If you see that in a piece of code, you know what the heck it is. And delete missing is deleting. Yeah. Delete missing is very distinctly deleting missing. This is fine. This is fine. This is good. Okay, well done. All right. Excellent result from our live stream today. Thank you very much to Bry C for that suggestion. That is great help. Okay, talk to you all soon, I guess. Actually, hold on a second. I was saving this in some crazy place.
Yes, SW nodes neural network.
For neural networks, you want me to save it in the neural network framework section? Okay, will do. Thanks. Okay, see y'all.
Bye.
Bye.
Thanks.